Hi everyone, myself Dr. Lakshmi Prasad, Professor in the MST Department in Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about Kruskal's algorithm, which is going to be used for finding the minimum spanning trees. So, according to Kruskal's algorithm, we're going to be select the edges in order to find the smallest weights and accept the edge if it does not cause a cycle. So normally for minimum spanning trees, I covered the videos about that in previous minimum spanning trees. So minimum spanning tree means, if I'm going to have a graph like this, so we have to be select the smallest weight in such a way that that should not form the cycle in Kruskal's algorithm according to that. So what is the minimum possibility of visiting all the edges of the graph in such a way that this is one minimum spanning tree and V1, V2, V3, V4 is under spanning tree like this. So this is one spanning tree, this is under spanning tree. So in what we are going to find the spanning tree by using this Kruskal's algorithm. So according to Kruskal's algorithm, we're going to find the smallest weight first and then how to accept that edge it does not cause a cycle. So normally this Kruskal's algorithm maintains the forest trees for trees. So initially we're going to have vertex in the tree with a single node, and we're going to be adding an accepted edge which is going to be merges the two trees into forest. So whenever the algorithm terminates, there is a single tree with more V vertices and it should be minimum spanning tree. So when it comes to the implementation of minimum spanning tree, it uses the disjoint set data structure to determine whether the edge connects the vertices in different components or not. So mainly this disjoint set data structure is heart of this Kruskal's algorithm for finding the minimum spanning tree. So what kind of operations you can able to perform on disjoint data sets is that make set of u, which is going to be used to create a new set whose only member is u, and find set is the under thing. So where you can able to return a representative element from the set that contains u, and so any set of elements, any of the elements of the set that has a particular property, and SU is thus where the property is that the element be the first one alphabetically. So find set is equal to R and find set of S equal to R. So this find set is able to return the same value for the given set. And another operation what we're going to perform is that union operation. So we're going to able to merge all the set values. Suppose if I'm going to have a set U which is going to contain the data RSTU and set V, VXY. So if I'm going to apply this union operations, we're able to club this both sets of this. And the running time of find set and union should also be depends on the implementation. So normally if I'm going to have a set like this, set A, and set B. So if I'm going to apply union operation, I can able to get 1, 2, 3, 4, 5, 6, 7, 8. So if I'm going to how this one is going to be present in the form of Venn diagram, I'm going to have one set U and another set B. So the data set should be 1, 2, 3, 4, 5, 6, 7, 8. So all the elements from the two sets should be reflecting in this one. So intersection means the data what is there in between the comma of the two sets should be the intersection part. So that means 4 and 5. So this should be for A intersection B. So like this, three kinds of set operations we can able to perform on disjoint data set. So first one is making a set and finding the set in the another one and applying the union operation. So this should be the Kruskal's algorithm. So initially we are going to have the vertex graph should be null. So for each vertex you have to make a set and have to sort the edges in non-decreasing order. There should be ascending order how to place it. And then for each edge in the set we have to find, and then that should not make a formal cycle. Otherwise, if it does not make a formal cycle, then it have to be added to the graph. So normally this Kruskal's algorithm is a greedy algorithm. So the Kruskal's greedy able to produce the globally optimal solution. So even though the Kruskal's is going to follow this greedy algorithm, it is going to be produce the global optimal solution. So initially we are going to have a graph like this. So should we have the set of disjoint set, all the vertices should be the disjoint, and this should be the minimum in between them. Weights are going to be assigned. So how this Kruskal's algorithm is going to be working here is that, so initially you have to be select the minimum one. So what is the edge is going to have the minimum that is going to be selected first. So among this one, so which is the minimum one is the minimum weight. So that's why I'm going to select the edge is V1 and V4 and V6 and V7. So these two sets are selected first since both these edges is going to have the minimum weight. And next, so among this one, so next minimum weight is 2. So that's why I'm selecting 2 here and this 2 here. So next 2 and this 2 I'm selected. So once this one is selected, so next I have to select 3 here. So 3 is the next minimum weight. So if I'm going to select this, so what will happen, it is going to form the cycle. So that's why I should not able to construct this one. And next if I'm going to select 4, so 4 is the next minimum. So I can able to select this. And next one, so I have to consider 5. So next minimum 4 is also there. So if I'm going to select this, what will happen? It is going to form the cycle. So that's why I should not consider this one. And next minimum 8 is that 5. So 5 is also not possible in order to form the cycle. So that's why it should also not be selected. And next minimum is 6, so it does not form the cycle, so I'm going to consider this. So next one, so what is the next minimum I can able to select? That should be 7. So in this 7, if I'm going to select this, so again it is going to form the cycle, so I should not be able to consider this edge also. And if I'm going to consider this, so it is also going to form the cycle. So this edge should also not be considered. So finally, the optimized minimum spanning tree is this one. So what should be the minimum spanning tree is that? So 1 plus 1 plus 2 plus 2, 4 plus 6. So totally 16. So 16 is the minimum spanning tree. Minimum cost spanning tree according to the Kruskal's algorithm. So how this Kruskal's algorithm is something different from Prim's algorithm. So normally the Prim's algorithm is going to be work in such a way that it should be selected the nearest edge. So first this one is going to be selected. So according to Prim's, if this one is selected, so next one is that, so I'm going to select the what is the next weight I can able to select is that 2, and next one is this one 2, and next I can able to select 4, 1, and from this what is the next one now 6. So like this I'm going to select it. So initially what I did is, so initially I'm going to select this vertex, and from this vertex it should be select 2, but next minimum weight is also available, so that's why 2 is selected here. So once this one is selected, next minimum 4, among this 1 and 6 it should be 1 and then 6. So it should be also same according to the Prim's algorithm. So how this one is something different from Prim's, means the Prim's grows one tree all the time, and the Prim's algorithm, Kruskal's algorithm grows multiple trees at the same time. So that is the only difference. So the Prim's grow only one tree all the time, whereas the Kruskal grow multiple trees at a time, and the trees are merged together using the same edge. And since the minimum spanning tree is going to have v mod v minus 1 vertices, so we would have only one component here. So let us consider another problem. So in this one, so in the given graph, so start with the vertex begins at one component, whatever you want here, and then repeatedly merge two components into one, choosing this lightweight edge that connects them, and the components are going to be considered at each iteration. So in this one, what I'm doing here is, so in this one, the vertices will be this, and next what I'm going to consider is, I'm going to sort all the edges in decreasing order of weight. So what should be the HG? First minimum is, so this one is going to add, and what should be the next minimum? CI, so 2 I can, GH also I can able to select, and next one GF, so what is the next minimum is that GF2, and add AB, so next minimum among this one is I can able to add CF, or I can able to add AB, so both are added, and next minimum is IG6, so 6 if I'm going to add, so it is going to form the cycle, so that's why this edge I'm not going to be considered. And similarly, next minimum is 7, so 7 is CD, so that's when I'm going to add, and next minimum IH, so if I'm going to consider this, it is going to form the cycle, so that's why I'm not going to consider this. And AH, next minimum is AH, so I'm going to consider this, and next minimum is BC. If I'm going to consider this, so it is going to form the cycle, so I'm not going to consider this one. Add DE, so this one if I'm going to add, does not form the cycle. And next one EF, so next minimum is EF, so if I'm going to consider this, that is going to form the cycle here, I'm not going to consider. And next minimum is this one, so if I'm going to add, so again it is going to form the cycle, and DF next, so this one if I'm going to add, so it is also going to form the cycle. Finally, this should be the resultant minimum spanning tree, so according to the Kruskal's algorithm. Okay, so like this we are going to be considered this Kruskal's algorithm. Similarly, what should be the Prim's algorithm, how the Prim's works. So according to the Prim's, so initially I'm going to be started here. So from the starting one, so if I'm going to select 4, So among this 4, I'm going to select 8 next minimum. So among this one, 2 is going to be selected out of 2, 7 and 8. And here I'm going to consider 6. Sorry, I'm going to consider among this 6. And from this one, it should be 1. And from this 7 is not going to consider, it is going to form the cycle. And 11, instead of 11, I'm going to select 8. So that is going to form the cycle. So next one, 2 is going to be considered. From this, I'm going to consider 4 will not be considered, it is going to form the cycle. So that's why I'm going to consider 10. And from here to 9. And from this, and this one is should not perform a cycle. So this should be the resultant graph according to the Print software. So what should we wait here? So 4 plus 8 plus 2 plus 6 plus 1 plus 2 plus 10 plus 9. So 12, 14, 23, 33, and then 42. So like this, we are going to consider reverse binary according to the Kruskals and the Print.
Like, share and subscribe. Hit the bell icon for more updates.